All right, guys, today we're going to look at function notation. Here we have some notes that are filled in for you. I want to point out a couple of things. First of all of the names of input and output, X and Y, are here. IV stands for independent variable, and DV, dependent variable. So this is independent, and then this is dependent. So when we talk about function notation, what we need to understand is basically it's just fancy way of saying, hey, use substitution. So here, the input is what we're substituting into the function. So we would read this as g of n, or the output would give us n squared minus 6. So think of the n squared minus 6 as kind of a machine. This machine right here will give you an output. So let's see here. We have h of m equals 3m minus 2. So we're asked to find h of 5. So we would say h of 5 equals 3 times 5 minus 2. So when I substitute or, do those calculations, 3 times 5 is 15, minus 2 is 13. So h of 5 equals 13. So m would be the input, which is 5, and the output is 13. Same thing with the other one. We would do h of negative 3. So h of negative 3, not a whole lot of space here, equals 3 times negative 3 minus 2. So h of negative 3, or if I input a negative 3, my output would be, let's see, 3 times negative 3 is negative 9. Negative 9 minus 2 would be a negative 11. So we're looking at negative 3, negative 11. All right, so let's try this next one. We have k of n equals 0.5n plus 3. So we are going to k of 6 equals 0.5 times 6 plus 3. 0.5 times 6 would be 3. 3 plus 3 is 6. So k of 6 equals 6. So our coordinate is 6, 6. Same thing with that next one. Let's see here. So k of negative 8 equals 0.5 times negative 8 plus 3. So k of negative 8 equals, so negative 8 times 0.5 is negative 4. Negative 4 plus 3 would be negative 1. So we're looking at negative 8, negative 1. So really, we're just looking at substitution here. I'm going to stop here, and we're going to continue these notes tomorrow. So, or Monday. I'm sorry, Monday. So hold on to them, and we'll get everything all fixed up.